715, which is titled More Conditions for Triangle Congruence. And we're going to answer the question, how else can I determine triangle congruence? So question 752 says, Kendall knows from her investigation in lesson 712 that even if two triangles have angles that are congruent, that would be angle, angle, angle condition, they are not necessarily congruent. But Kendall wonders about side, side, side triangle congruence condition. So for part A, you're going to be making a prediction. Okay? Do you think that two triangles are congruent if all three pairs of the corresponding sides are congruent? On this line, you're going to write down what you think. You're making your prediction. You don't even have to have the same answer as the person next to you. You're going to write down what you think. I think, and then you're going to write what you think. Do you think the two triangles are congruent if all three pairs of the corresponding sides are congruent? So you're going to write a complete sentence. I think, and then fill it in. Okay? Part B says, investigate Kendall's idea. To do this, you can use the online tool. So when we're done or when you're at home, you can go on and look at that tool, and it'll help you do it. Or we're going to do it using the straws. Can you create another triangle with the same side lengths that is not congruent? You're going to sketch your triangles and write down your conclusion. All right, so I'm going to create a triangle on my paper. You're going to create the same try and create the same triangle, and we're going to see if they're congruent. So I'm going to use the red, the orange, and the yellow. So go ahead and pull the red, the orange, and the yellow out of your bag. And create a triangle. The best you can. They're not perfect. All right. The question is your triangle congruent to my triangle? Does it have to face the same direction in order for them to be congruent? No. Does it have to be flipped the same direction in order for them to be congruent? No. But are they congruent? Could you turn yours or flip yours, and would it be this congruent to mine? Yes. So you're going to say if the corresponding sides are congruent, then the corresponding angles are going to be congruent, which is going to mean that the two corresponding triangles are going to be congruent.
But I thought if it's angle, angle, it's not.
This isn't angle, angle, angle. This is side, side, side.
Or, well, yeah, sorry, side, side, side. You can't figure out an angle, therefore.
You don't need an angle on that one. Side, side, side is going to work. That's question C. Is side, side, side a valid triangle congruence condition? And you're going to say yes. Not the same as angle, angle, angle. Because it's side, side, side. All right. Question 753 says, Kendall is excited that her team found a new triangle condition, side, side, side. But now she wonders if she needs all three sides to determine triangle congruence. You can use this online tool again, or we're going to use the straws to determine if side, side is a valid triangle congruence. Side, side is not enough to prove that the two triangles are congruent. You and your partners will not have the same triangle, okay? So question 754 says, Kendall's teammate Diego spoke up. We know that side, side congruence does not work in most cases, but what if the two corresponding angles are on right triangles? Like in my diagram, I know for sure that these two triangles are congruent, okay? What's special about these triangles?
They're the same.
Well, yes, but they both have a what? A right angle, okay? So you're going to take your protractor, and this little hole, if you haven't used a little protractor, is where your vertex should lie, okay? Which is roughly where the middle of your paper clip should be, but you're going to open up your paper clip so that it's as close to 90 degrees as you can get. You need to do it, and then when you're done, hand the protractor to your partner because they need to do it as well. You need to get your paper clip to 90 degrees, and they need to get their paper clip to 90 degrees, because there's two triangles with 90 degrees, right? Okay. Once you've got your 90 degrees, we need, what colors? We need yellow, orange, and purple. You're going to slide on the yellow on one side. You're going to slide the orange on the other. Oh, no, you need to slide, you need to slide yellow on one side because that's the side they have congruent. So you both need to slide on the yellow. Then you're going to take the purple and it's going to be the hypotenuse. The hypotenuse should be directly across from the right angle. So we've got the hypotenuse congruent, we've got a leg congruent, and we know that it's a right triangle. What piece has to fit right here? The orange. Is there any other piece that could fit there? Because you can move this purple around, could red fit in there?
No.
What happens to that angle over there? It's not the same anymore, right? Okay, so it has to be the orange in order for it to be a right triangle. That little box and that little box forces it to have to be that right angle. Okay, so question A says, how does he know that the two triangles are congruent? Explore this using your tools. So if you were to use the Pythagorean theorem, you would get the same result. And so it says, recall that the sides of right triangles have special names. What would be a good name for the congruence condition that Diego has discovered? Hypotenuse leg, yes. The right triangle is the only triangle that has a special side called the hypotenuse. So this one has a special name called hypotenuse leg. And for short, you can just call it HL, hypotenuse leg. All right, I'm going to move this up. You'll see it in just a second. There it is. All right, question 755 says, you have tested several different triangle congruence conditions like angle, 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 side, 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 and even side angle, side angle, side angle. You have found that some of these conditions are valid and some are not. What other possible triangle congruence conditions might there be? List the names of every possible triangle condition you can think of involving corresponding side lengths and angles. So on your paper, you're going to write all the ones that you could ever think of, right? Because you have more than 3 sides. No, because triangles only have 3 sides. Could you have more than 3 angles? No, there's only 3 angles. Okay, so you can do any combination of angles and sides as long as you don't have more than 3 sides and more than 3 angles. So on your paper, you're going to list as many as you think there might ever possibly be. Go. You got about 30 seconds. Write down all the possible choices you think it could be. All right, question 56 says, Carlos then asks, what if we only know that one angle is congruent and 2 pairs of corresponding sides that make the triangle are congruent? Does that mean the triangles are congruent? So we're going to use straws again to test the side, angle, side triangle congruence condition that Carlos is proposing as described below. Okay, so here's our triangle. We're going to create this triangle. So the degree in here is how much? 20. So you're going to take your protractor and you're going to take your paper clip and you're going to shrink your angle down to 20 degrees. Smaller angles are harder to make, so it takes a little patience, but that's roughly it. Okay, so it should be about this big. Remember, the little hole is where your vertex should roughly be. And then the 20, if you're going to the right, is on the inside number. And if you're going to the left, it's the outside number. Just depends which direction you're going. Okay? To the left, it's the outside number. To the right, it's the inside number. Okay? Once you've got your 20-degree angle, make sure your partner has a 20-degree angle. So hand the protractor to them. Let them create the 20 as well, because you both need to make one. Then we're going to look for the side measures. We have a 4 centimeters, which we have inches, so we're going to use orange. Then we have a 5 centimeters, which we're going to use inches, which is purple. And so that creates a side angle side. Could your partner put one color and you put another color?
No.
To create your third side? No. You both have to put the same color, which is what?
Red.
Red. Well, it's a little bit smaller than red, but yes. It's right there, just like that. So is side angle side a triangle congruence? You're going to say yes. If a second triangle has these same measurements, is the second triangle congruent to the first? You say yes, they will be congruent. All right. Part B, test your idea from part A on the additional triangle below. Is it possible for the two triangles with the same measurements that are not congruent? So for this one, we have 120 degrees. So you're going to take your paper clip. You're going to open it up all the way to 120 degrees. So it should be pretty big. Takes a little bit of adjusting to get it there. There we go. There's 120. Should be nice and wide. There's your 120. Then you're going to find the two sides. So 4 centimeters is orange. And 3 centimeters is yellow. You're going to discover that you don't have the right size. You should actually have one that's 6 centimeters, but there aren't enough color straws. So I'm going to prove it to you with my ruler, my fancy ruler over here. You take it, and this should be where it fits in to 6. 1, 2, 3, 4, 5, 6. Should be, if you had a straw that was 6 centimeters, that is what would work. So from the orange corner to the yellow vertice, that would be, but we don't have a color straw that's 6. If you look on your list, it jumps from 5 to 7. All right, but yes, they would also be congruent. We just don't have the right size. Part C says, based on your investigations from parts A and B, what can you conclude about triangles with side-angle-side congruence? That you can rotate and translate them, but the two triangles are going to be congruent. Whether they're flipped or turned or whatever, that doesn't matter. They're still going to be congruent. Okay? Question 57. Corey's team puts side-side angle on their list of possible triangle congruence conditions. To test their idea, Corey started by drawing the triangle at right. We're going to use straws to investigate whether side-side angle is a valid triangle congruence condition. Can you create a triangle that is not congruent to Corey's? Okay? So we've got a 49 degree over here. So you're going to take your protractor. You're going to open it up to how many degrees? 49. That's really close to 50. So probably right about, it's too narrow. A little bit more. Okay, that's about 49. Then we've got after the 5 centimeters, so purple.